Now we're going to use cluster analysis to analyze our insurance data set. So as before, let's load in ggplot and flexclust. So we're going to need those guys. Whoops. There we go. And let us read the data in. Let's go down here. And if you recall, this data set has been scrubbed. So if I do head df, there you go. Look, the data is all been scrubbed. We don't have any missing values. We have them all imputed. And we have a lot of flags here. Like, for example, this one says I'm a male and I'm a clerical worker. You know, my car is a panel truck. I've got a lot of flag variables and numeric variables. Now, as with principal component analysis, we do not want to use flag variables in our clusters. You only want to use continuous variables. So we're going to only use those. So let's start off by first making a copy of our data set. So I do head df principal component analysis. There you go. So we've got the data set. Now, because we are going to do cluster analysis, just like with principal component, we don't want the targets in there. We only want to use the input variables. So let's get rid of the targets. And how do we do that? Well, we just set them to null. So you see they're gone now. Now the next thing we want to do is we want to get rid of the flag variables. Like this guy right here is a flag variable. Anything that starts with the letter M in this data set was a flag, and anything that has the word flag in there is a flag. So these are the variables that we have that are, we don't want to use those. So we could do this a lot of different ways. There's many ways to do things in R. So if you see in a previous lecture I did it differently, there's no one way. This is just the way I happen to do it, is I'm going to just say, hey, listen, we're going to make a copy of this guy, and we're only going to use columns 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 14, 16, and 18. Those are the guys that only have numeric values. And then when I get over here, I skipped him, and I skipped him, and I skipped him. So let's do that and see what we get. So now if I do head df principal component analysis, I only have the continuous variables here. Now we could, in theory, start to cluster right now. But one of the problems that you have with cluster analysis is that it tends to give too much weight to big numbers. So in other words, if I clustered this, the blue book value of the car's value, the person's income, and the person's home value would overpower all the other variables. So they all have to be on the same scale. Now, if you recall, back when we were doing principal component analysis, we could standardize all of these things and put them all on a scale of plus and minus 3. We could do that, and that would probably be, it's a more advanced technique, and probably if I were spending an entire class on cluster analysis only, I would probably do that or explore that. But in the interest of time, another technique, a very good one, is to cluster principal components. So what we're going to do is we're going to come down here and we're going to do principal component analysis of this guy right here, that we just created, and we're going to scale it. So we're going to ask principal component to please scale this data plus and minus, to plus and minus 3. So let's do that real fast. And so now, if I were to, summary principal component analysis. So there we go. We've got our principal component analysis model right there. So what we'll want to do is a scree plot to see how many principal components we should use. So let's plot this. And there it is. So we have right about here is where it starts to drop off. So maybe 4 principal components, I don't know. We could do 4 principal components here, maybe 3 if we wanted to. So that's kind of how what we'll do. So let's, just for fun, to keep things simple, let us only use 2 principal components. And the reason why, if I was going to do this in the real world, I might use 4. But what I want to do here is show you some graphs of what we're looking at. So let's just use 2 of them right now. And I'm going to copy, let's use this model, PCA, and we're going to predict this guy using this model in our data set, and we're going to shove those answers into dfnew. And you see I've got nothing but principal component analysis, and you'll also see we have 14 principal components. Why? Because we had 14 variables. You get 1 principal component for each variable. We're only going to use the first 2 here. Now we could, like I said, if I was going to do this in a real world situation, I'd probably use at least 3, maybe 4 of them. But I'm only going to use 2 because I want to show you, I want to graph some of this stuff. So let's copy k-means, and we're going to copy the first 2 principal components, and we're going to put it into a new data frame called k-means. Let's do that. So now, whoops, how about k-means? There we go. So now we got those first 2 principal components, and let's graph them. Now, that is not a very compact and well-separated data set, but let's see what we can do with that. Well, how many clusters do you see there? I don't know, maybe 2, maybe more, who knows, but there are a lot of them clumped together. Maybe here's a cluster, it looks like, maybe here's a cluster, I don't know. Let's see. Well, what we'll do is we're going to run that same code that we ran before. We're going to say, let's have at most 10 of these guys, and let's just loop through over and over again, and then do a scree plot and figure out how many clusters we have. And there we have it. 1, 2, 3, 4, maybe 5. I don't know, 4, 5. Let's go with 4. Let's just see what 4 gives us. And I've already ran this once before and decided on 4. So now let's go over here and cluster this. And we set it to 4. So we say, let's cluster this k-means 4. Remember, because best up here is, best is right here, 4. And then we're going to have 20 starting points and find the best one. And here's our, whoops, that's not what I wanted. I wanted to do, well, that is what I wanted. Okay. We have cluster 1 has 2200, cluster 3 has 36, 2400, and 1800. And these are the cluster centers. And of course, we are going to convert them into flex class. And let's look at our bar plot. And there they have high values for principal component 1 and 2. Principal component 1 and 2. This guy's low, this guy's medium. These guys really low, nothing, really low, positive. So I got 4 different clusters, and I can see that they seem to be very different from one another. Let us, because we have this flex class guy, we can use the predict command. So we're going to predict, and we're going to predict this guy here, and we're going to shove the answers into class. Okay, now if we go up here and let's take a look at our plot one more time, this is what we had right there. And now we're going to plot with color. So let's go down here and plot. Voila, there we go. Now, it wouldn't be neat if we were able to have a legend, blue, red, black, and green here. Wouldn't it be neat if we were able to actually show what these are? Well, here is a command for you. I can put a legend on my plot, top right. I'm going to make that top left for this guy. And then the legend is going to be 1 through best, which is 4, right there. And we're going to fill in the colors 1 through 4. So let's put that legend in there. And there it is. So you could see that cluster number 1 is this guy right here. Cluster number 2, the red guy, is right over here. Cluster number 3 is this guy. And cluster number 4 is this guy. Now, why don't we, I'm kind of curious as to what these, well, first of all, I'm curious if these clusters are predictive of whether or not you're going to crash your car. Well, we can find that out. Let's put this guy right here, the clusters, into our data frame. So now if I do head of my data frame, you can see I have my targets and all my variables, and then way down here at the end I've got my cluster. Now let's aggregate my target flag, did I crash my car, by my cluster, and let's see if that's predictive. And if I type aggregate, look at that. So cluster number 3 has a 42% chance of crashing your car. Well, who's cluster number 3? That's this guy down here. So apparently a low value for principal component 2 and a higher value for principal component 1 suggests that you're going to crash your car. This guy, cluster number 1, has a 35% chance of crashing your car. So he's got a high value for principal component 1 and a high value for principal component 2. So probably this guy is associated with safety. What about number 4, this blue guy? He's got a real low value and he's got a low value. So apparently this is my safe cluster, this is medium, this is dangerous, and this is really dangerous. Now, how can we interpret these? So if somebody says, what is cluster number 1? Your boss wants you to interpret it. I'm about to show you how to interpret clusters when you got lots of variables. Well, what I'm going to do is I'm going to go and take my principal component analysis data set, and I'm going to copy him into another data frame I'm going to call tree. So let's copy him over. Data frame, head, data frame, tree. So there they are. So I've copied all of the raw variables here. Now let's put our friend the cluster in here. So data frame, cluster, and I'm going to copy this guy into it. Now you're going to notice I put this command here as factor. In other words, what does that do? What that's going to do is it's going to tell R that these 1, 2, 3, 4, 5 is not, these are not numbers, these are clusters or factors. They 1 and 2 and 3, these don't, 3 is a cluster, it's not a number 3. So I got to tell that to R. So that's what this is doing. Okay, now let's build a decision tree. We're going to say we want you to predict the cluster using all of the variables and using this data set. Now remember, 3 is the dangerous one and 1 is the next dangerous. 4 is the safest. So 3 is dangerous, 4 is safe. So let's build this. And error, what happened here? Oh, I didn't load in the libraries, I'm sorry. There they go. Now if I draw the tree, let's see what it tells us. Oh, that we can't see that. So let's expand it and then build it again. Whoops. There we go. That's easier to read. Now remember, 3 is our dangerous cluster. Well, what is 3? Well, if you look at this decision tree here, these gray guys are all cluster 3. Well, how do you get to be in cluster 3? Well, let's look. The oldest claim, in other words, how much money did I have to pay in the last 3 years to fix your car? If it was a little bit of money, I go this way. If it was a lot of money, I go this way. So you can see, if you're in cluster 3, I've had to fix your car and spend lots of money fixing your car over the last 3 years. So you've been crashing your car a lot. So you're over here. Then I say, have you had a lot of speeding tickets? Yes, you have. So I've spent a lot of money fixing your car and you speed. You're a risky driver and you aren't very good at driving. Okay, well, what about the guy who didn't get a lot of speeding tickets? Well, we go over here and it's like, did I even have to pay more money? Okay, yes. And no, okay. So then we say, this is, we go over here and we have claim frequency. Even though I didn't pay a lot to fix your car, you crashed it a lot. 3 or 4 fender benders. So this is really, if I was going to describe cluster 3, I would say this is a guy who crashes his car a lot and he likes to speed. So yeah, that makes a lot of sense that this guy is dangerous. What about guy number 4? Remember, 4 was considered to be pretty safe. How can we describe him? Well, I don't know. Let's find out. He ends up over here and here. Okay. Well, this guy did get into an accident because it's over here. He's on this side of the tree. So he did get into an accident, but he doesn't speed and it wasn't an expensive accident, and he's got a lot of money because his income is pretty high, and he hasn't crashed his car very much, and he's got an expensive car. So, or an expensive home. So this is like a rich guy who drives kind of safe. I would say wealthy person who drives, who doesn't get into accidents. What about over here? He didn't get into an accident and he's got an expensive car. So really, this is, I would call cluster 4 wealthy people. They seem to have a lot of money. They drive safe and they have a lot of money. Okay. So what about cluster 1? Well, if that's over here, they didn't crash their car, but they have their house is cheap. They don't make a lot of money and they're young. So young, poor people. So these are probably college, young boys right out of high school. And then over here, this is a guy who is older and he seems to be, but he has only been on his job for 4 years. So this guy is an older guy. He's not wealthy, he's older, but he can't hold down a job. If he's only been on his job for 4 years and he's over 46, that might suggest that he's irresponsible. But this is how you profile people. You use a decision tree. So anyways, this is a general idea how we can cluster our real world data. Now we're going to try one more case where we kind of take this down a little bit more in the next lecture.